Question 9. Two trees on level ground, 12 metres apart, are joined by a cable. It is attached 2 metres above the ground to one tree and 11 metres above the ground to the other. What is the length of the cable between the two trees, correct to the nearest metre? Let's analyse this diagram. The question is asking for the length of this cable here. So this is the cable that joins the two trees, and I've indicated that with the variable x. The next thing to note is that this side marked with an x is part of this trapezium here. And the two parallel sides of this trapezium are the lengths of the trunks of the two trees. So the shorter parallel side is 2 metres and the taller parallel side is 11 metres. In fact, if we turned the question paper around, you can see the trapezium a little bit clearer. And the height of the trapezium, which is the distance between the two parallel sides, is 12 metres. Now this has some significance in helping us find the length of this side here, marked with x. If we can divide this trapezium up strategically, we can then apply Pythagoras' theorem to find the value of x, which represents the hypotenuse of a right-angled triangle. And given the type of trapezium that this is, we can divide it up into a rectangle and a right-angled triangle and then apply Pythagoras' theorem. So I've drawn a dashed line here to act as a divider that divides this trapezium into a rectangle with length 12 metres and height 2 metres, and a right-angled triangle. One side of this right-angled triangle, or one of the short sides, is 12 metres, since opposite sides of a rectangle are equal in length. And the other short side of this right-angled triangle, so let's call it the height, is 9 metres, since 2 metres plus 9 metres should give us 11 metres, which is the length of the trunk of the taller tree. Now that we have the two short sides of this right-angled triangle, we can then apply Pythagoras' theorem. And here it is. So x squared is equal to 12 squared plus 9 squared. Evaluating 12 squared plus 9 squared, we get 225. So x squared is equal to 225, but we want the value of x, not x squared. And if we look at 225, it obviously sounds a little bit outrageous that it's such a large value compared to 12 metres and 9 metres. So there is one more step, which is to take the square root of 225 to find the length of x. So taking the square root of 225, we get x is equal to the square root of 225, which equals to 15 metres. So that represents the length of the cable joining the two trees. Therefore, the correct answer is option C.